graph, I think it makes more sense. I think it's a little more straightforward, okay? But sometimes it's hard. Sometimes the graph is hard, okay? Sometimes you need to do this, okay? This is a bit more complicated, but sometimes it's the best way to go. And whichever way you go, if you do one and you do the other, it'll help you know you got the right answer, okay? So, think about it like this, okay? You've got this. This is the parametric equation for x, right? Now, if I'm trying to find the restriction on x, in some ways, I ought to be able to work it out just from this equation, okay? And the question is, how, right? Remember back, I rubbed it off, but we worked out that PQ is equal to 2, right? So that means that Q is equal to 2 on P, right? Now, when I've got this, I can put that into here. And now what I have is really useful because it's an equation with just x and just the parameter. Okay, just x, just the parameter. Now the reason why that's important is because I know that the parameter has to exist. There has to be some solutions that make this work. Okay? Now you're like, well, what difference does that make? Okay, let's do this. Because this is all about quadratics, okay, I'm going to turn this into a quadratic equation. But it's not a quadratic equation in x, is it? Why not? But why not?
Why not?
Wait, what did you say is not a quadratic equation of x?
This is a quadratic, but it's not a quadratic of x. Why not? Because it's p squared, there's no x squared, okay? Right, so keep that in your head, because that'll be important. Let's get it into general form. So p squared plus px, minus px plus 2 equals 0. Okay, now stop. Remember I just told you, this is the parameter, right? And the parameter has to exist. There have to be some solutions for this, right? So, if there are solutions to this, what does that mean about its discriminant? If a quadratic if it's got solutions, its discriminant has to be greater than or equal to 0, right? Because if it's negative, right, there are no roots, no solutions to this equation. So P breaks, okay? All right, now, the discriminant is b squared minus 4ac. But be careful, because this is a quadratic in P, not in X, what's b? It's, b is minus x. Okay, be careful. Now, I know in this case I'm squaring, it doesn't matter, okay, but that coefficient is there, it's important, okay? So b squared is that. Minus 4, a is equal to its monic, okay, and c is equal to 2. Okay, see that? All right, so now x squared minus 8 greater than 0. Okay, do you see what just happened? Okay, now we're back in where we started, okay? Now some people will just graph this, but you know, it's pretty simple. X squared minus 8 was down below, and I want the parts that are positive, okay? So if you want to, there's minus 8, so that's my minus 2 root 2, there's my 2 root 2, okay? And I want where it's above, so that's this part, just like here, okay? So, therefore, x is less than or equal to that one, or greater than the positive one. That's a really guide too. Okay? Now, which method do you like? Which one do you think is shorter? The second one's probably marginally shorter, I think. Okay? Very, very marginally, maybe 1 or 2 lines. However, the disadvantage is that it's kind of like, well, where did we pull this out from? Why did we even do this? It's a little less obvious than, well, look, I looked at the graph and these are the parts that work and these parts that don't. Okay? However, I think you've got to know both. Okay, sometimes method 1's better, sometimes method 2 is better, sometimes significantly so. So you don't want to lock yourself into, I always do it this way, and then you'll meet some question where the other way is better and you'll be like, oh, I'm stuck. Okay? Okay.